Here we look at another buffer calculation. We've been given information, and from this information we've been asked to work out the pH of a buffer, and then we need to work out the pH of the buffer after we add 5.0 times 10 to the minus 4 moles of sodium hydroxide. So we need to apply what we looked at in the buffer action video to this buffer calculation. So remember, if I want to work out the pH of a buffer, the first thing I'd write down is H plus is equal to the Ka times HA concentration over A minus. I will stress now, this is really important, you can use either moles or concentration for these values. However, if you're using moles, there has to be moles of both. Now, in this particular question, you've been given the moles value for the salt, which is called an NaY, but you've been given the concentration of the weak acid. So what you have to do is you have to convert this concentration of weak acid into moles. Okay, you have to make sure that both of these are either both in moles or both in concentration. So the first job that you need to do is convert this, we're calling this weak acid HY, into moles. So I would say then moles of HY, that's the first thing I'm going to do. That's equal to, moles is concentration times volume. So it's 0.428 times 50. Again, got to convert that into decimeters cubed. When we do that, we get a moles value of 0.0214 moles. Now, I've got my units consistent. I've got moles of HY and moles of my Y minus in this case. So I simply now put them numbers into my equation. So my H plus is equal to the Ka, which is given. It's 1.35 times 10 to the minus 5. Multiplied by my HA, or in this he's calling it HY, 0.0214. Divided by my A minus or Y minus, it would be in this case of 0.0236. When we do that, we get a hydrogen ion concentration of 1.22 times 10 to the minus 5 moles per decimeter. And then obviously we just minus log to the base 10 of that answer. And that would give me a pH of 4.91. So that's the pH of this buffer. That should be quite straightforward. We're simply using this equation. I think the tricky bit there, again, is to make sure that you convert this into moles. So both your A minus and your HA units are both moles. So I've got this buffer solution now, and I've now added sodium hydroxide. So if we apply what we said in the buffer action video, what we've got then is I've got my HA in equilibrium. It's from H plus A minus. And we've added hydroxide ions. If I add hydroxide ions, the equilibrium is going to shift to oppose the change. And it's going to shift to increase the amount of hydrogen ions that are formed. So the hydroxide ions will react with the hydrogen ions, cause the hydrogen ion concentrations to go down. So the equilibrium will shift to oppose that and shift the equilibrium to the right. This means that your A minus concentration now will increase by the amount of sodium hydroxide added, which we said there is 5 times 10 to the minus 4. So this will increase by 5 times 10 to the minus 4, and therefore the HA, that will decrease by 5 times 10 to the minus 4. So let's just have a look at what my initial moles of A minus were. My initial moles of A minus was this. It was 0.0236. My HA was 0.0214. So now we would say moles of HA is 0.0214 minus 5 times 10 to the minus 4. And that would give me 0.0209. My moles of A minus is going to be 0.0236 plus 5 times 10 to the minus 4. And that would give me 0.0241. So let's just examine that. We've said then that my A minus will increase by 5 times 10 to the minus 4. My A minus originally was 0.0236, so it increases by this amount to give 0.0214. My HA, my weak acid, was 0.0214, and that's going to then decrease by the amount of sodium hydroxide added. All you do now is you simply stick these numbers here back into this equation. So that then will give me a hydrogen ion concentration then of equal to my Ka, which again is 1.35 times 10 to the minus 5. Now times, and this is going to be 0.0209 over 0.0241. And when you do that, you get hydrogen ion concentration of 1.17 times 10 to the minus 5 moles per decimetre. And then, of course, you have to minus log the answer. And you get a pH there at 4.93. And again, common sense would tell you, because you've added hydroxide ions, the pH will increase a little bit, but because it's a buffer, it's only going to increase by a very small amount. So that there would be how, firstly, you work out the pH of a buffer, and then how the pH of the buffer changes when you add small amounts of hydroxide ions.